Well, dear friend, there I have written some questions, objective type from radioactivity on the board. You have to find the correct answer. For uranium nucleus, its mass m varies with volume V as. For uranium nucleus, its mass m varies with volume V as. A m proportional to V, m proportional to 1 upon V, m proportional to under root V, m proportional to V square. So which option is correct? Here we will use the fact density equal to mass upon volume, and density of nuclear matter is constant quantity for every nucleus. Whether it is the hydrogen nucleus, neutron or uranium nucleus, density of all same. Since density constant, so m proportional to V. First option is correct. I hope you have got my point. For uranium nucleus, its mass m, mass of nucleus, proportional to volume V, proportional to 1 upon V, proportional to 1 upon under root V. And listen, this question has been asked in JE 2003. I know these questions are simple, but you people may not read just for the knowledge. The first option is correct. Now, there is question during beta decay. During beta decay, electron emitted originates from number 1 A part, inner orbit of the atom, free electron existing in nucleus, decay of neutron in the nucleus, D part, photon escaping from nucleus. I have told you beta decay. ZXA अगर बीटा डिके है तो दैट इज -1 E0 प्लस Z प्लस 1 YA प्लस न्यूट्रिनो एंटीन्यूट्रिनो प्लस 2. तो Z प्लस 1 कहाँ से होगा? If a neutron here decay into proton, तो 0 and 1 is equal to 1H1 plus -1 E0 plus. So therefore answer is here decay of neutron in the nucleus causes the electron emission in beta decay. Radioactivity is a nuclear phenomena. There is nothing to do with the electron present in outer orbits. Okay. Now, again a good question. Yes, this last question was asked in JE 2001. The coming question has not been asked anywhere, but question is good. Masses of two isotopes 29 Cu64, 29 Cu64 and 30 Zn, zinc. 60 isobars, I told you, are the atoms of different elements having same mass number. Their masses are 63.9 to 98U, 63.9 to 92U respectively. It can be concluded from the data that both are stable. Zinc 64 is radioactive decaying to Cu through beta decay. Zn, the atom number of Zn is 30 and that of copper 29. During beta decay, atom number increases by 1. So this is not possible. Okay, beta decay may take place, but if zinc decay by beta emission, then during beta decay atom number increase by 1. तो should be 31 while it is 29, तो ये तो possible नहीं है. Then Cu64 radioactive decaying to Zn64 through gamma decay भी नहीं हो सकता, because in gamma decay neither atom number nor mass number changes, so this is not possible. Cu64 2964 is radioactive decaying to Zn64, yes, through beta decay, because अगर ये decay होता है Cu64 तो -1 E0, जिसको हम बीटा बोलते हैं, बीटा माइनस, तो मास नंबर विल इंक्रीज, एटम नंबर विल इंक्रीज बाय 30 Zn. Mass number does not change, plus and neutrino. So we can conclude that copper is radioactive, decaying to zinc 64 through beta decay. So these were 3 questions here asked in competitive exam. Now there are more questions here, but to save time I will read only, and you can next question is there. The nuclei have mass number ratio 1:3. Nuclei have their mass number. Mass number is A1 A2 is equal to 1/3. So you are asked here the ratio of their nuclear density of nucleus are number in the ratio, are in ratio 1:3, B part 3:1, C part 1/3 to the power 1/3:1, and D 1:1. Abhi just now in the first question I told you that density of nuclear matter, यानी कि density of nucleus of every element is same. We have proved there. Actually density जो है mass upon volume, and volume is equal to mass होगा, mass number A upon n, volume होगा 4/3 pi r cube, or in fact r equal to r0 a to the power 1/3. If we put this value of r, so we get a, so a get cancelled, so density of nucleus for all element, all the element independent mass number, so it is 1:1. Remember this very important question here, the density of nuclei of all elements is the same, whether it is the nucleus of uranium or radium or carbon or nitrogen. Density of the nucleus of all element is the same, so it is 1:1. Now here is a good question. A radioactive nucleus, initial mass number A and atom number Z. Radioactive nucleus mass number A and number Z emits 3 alpha particles and 2 positrons. So the ratio of neutron to proton, ratio of proton to neutron, ratio of neutrons to protons of the resulting nucleus, find nucleus. A minus Z minus 12 upon Z minus 4. B, A minus Z minus 4 upon Z minus 2. C, A minus Z minus 8 upon Z minus 4. And D is A minus Z minus 8, 4 upon Z minus 8. So which ratio will be there? It emits 3 alpha particles and 2 positron. During positron are emitted when proton decay into neutron. Do you know? 0, 1h1 inside nucleus decay into 0 and 1 plus positron or plus neutrino. So for each positron a proton decay into neutron. So corresponding to emission of 2 proton, number of neutron will increase by 2. For each alpha particle, 2 proton and 2 neutrons are emitted. So for 3 other particles, 6 protons are emitted and 6 neutrons are emitted. But due to this 2 proton has increased, the number of protons has become Z minus 4 or neutron 6 minus 2. Are you getting me? For each alpha particle, मैं लिखता हूँ. For each alpha particle, nucleus loses 2 protons and 2 neutrons. While for each positron emission, nucleus loses 1 proton and gains 1 neutron. Therefore, number of protons will be Z minus 6 3 into 2 or plus minus 2 into 1. So it becomes how much? Z minus 8, 6 or 2, 8. Number of neutron, that will become A minus Z, तो पहले से थे वो, minus 3 into 2 plus 2 into 1. So it is A minus Z minus 6 plus 2, 4. So it comes here, D part, A minus Z minus 4 upon Z minus 8. Here this is a good question, and this question has been asked in AI E 2010. But for each other particle, nucleus loses 2 proton and 2 neutron, while for each positron here, each one nucleus loses 1 proton and gain 1 neutron. So number of proton will be Z minus 2 3 जा 6 और माइनस 2 प्रोटॉन लूज हो गए तो Z माइनस 8 बच गए प्रोटॉन. न्यूट्रॉन पहले से A माइनस Z थे उसमें और 3 2 जा 6 लॉस होगा, 2 into 1 गेन हो गया. तो it becomes A minus Z 6 minus 6 minus 2 4. तो दिस ऑप्शन इज करेक्ट. ठीक है भाई. नाउ नेक्स्ट क्वेश्चन हियर इज देयर. Nucleus of uranium decay at rest. ये न्यूक्लियस यूरेनियम का रेस्ट पे था. Decay into thorium and helium. Actually 92 uranium 238 है होता हो. It decay into 2He4 और प्लस 90 थोरियम 234. तो यू आर गिवन हियर ऑप्शंस ड्यूरिंग दिस डिके. ऑप्शन ए, हीलियम न्यूक्लियस हैज ए पार्ट. हीलियम यानी कि 2He4 हैज लेस momentum. Helium nucleus has less momentum than thorium. B, helium nucleus has more momentum than thorium. C part. C option. He nucleus had less kinetic energy than thorium. B part. Helium nucleus had greater kinetic energy than thorium. हाँ भाई. तो which is correct? This nucleus was at rest. No external force there, and from law of momentum, initial momentum equal to final momentum. तो चूंकि momentum was 0, तो momentum of helium P of He is equal to P of thorium. तो ये तो सब गलत हो गए कि मोमेंटम कंसेप्ट तो इक्वल है. नाउ वी नो काइनेटिक एनर्जी इक्वल टू P square by 2m. If two bodies having same momentum have different mass, तो naturally heavier mass will have lesser kind energy. So which one is there? Helium nucleus has greater kind energy than thorium. तो देखो क्वेश्चन तो एक नंबर का है, बट you are asked here law of momentum also. I hope you will enjoy this video. Please like video, share, and please ask student to subscribe my channel. Thank you.